Okay, let's talk about piecewise functions. A piecewise function is a function that has different equations for different values of x. So we'll say different equations for different values of x. All right. In other words, it combines multiple functions, each with its own specific domain. So when you're writing a piecewise function, you're going to have several different parts. Here is an equation, and then you're going to specify the domain that goes with that equation. Okay, and you can have 2 different equations, you can have 7 different equations. It just varies based on which function you're into right now. All right, so this one has 3 equations. And the idea is this equation will be -2 anytime x is less than or equal to -4. Then after -4, it's going to switch to x plus 1. And that will happen in between -4 and 2. And then it will switch to 3/2 x minus 2 when x is greater than 2. So let's graph these 3 separate pieces. It is helpful to know where each function sort of breaks up. So we know that this first part is true when x is less than or equal to -4. So at -4, the y value, the function value, will be -2. And I'm going to make that a closed -2 because of this symbol right here that says less than or equal to. Okay? And then anytime x is less than -4, so when x is -5, the function value will be -2. When x is -6, the function value will be -2, and so on and so forth. So less than -4, you have a function that looks like this. Okay, let me see if I can change my pen color here. All right, so then the next domain that we're interested in is in between -4 and +2. And note that right here, there's no equal sign. So I want to know would this function be at -4 if it were allowed to equal that. Okay, so what I'm going to do is I'm going to find g of -4. And if I plug -4 into this spot right here, I get -4 plus 1, which ends up being 5. Okay, so if this were an equal sign, then at -4, this function would equal 5. It's not an equal sign. So the way we indicate that is we say there's an open circle here at -5. Okay, and then I'm interested in what g of 2 is. And if I plug 2 in to the g function, I get -2 plus 1. And -2 plus 1 is -1. I am allowed to equal 2 at this point in the domain, so I'm going to say at 2, g of 2 is -1, and that is a closed circle. And this is a line here, so in between this point and this point, I have a slope of -1. I'm going to connect these 2 points. All right, and that is the second piece of this piecewise function. The third piece, all right, is going to come from this last chunk. We're going to look at the domain x is greater than 2, strictly greater than. So I still want to find g of 2, but for this green spot. What happens if I plug 2 in right here? And if I plug 2 in right here, I would get 3/2 times 2 minus 2, which is 3 minus 2, which is 1. So the function does not equal 2 in this bottom chunk, but it goes right up to 2. So g of 2 is going to be 1, and that is an open circle. Okay, and then anything greater than 2 is going to follow this line. So you could find another point that's greater than 2. I could plug in 3 or 4. I could also just use this slope here to guide me. It has a slope of 3/2. So from here, I know that I'm going to go up 1, 2, 3, and to the right 2. I'm going to go up 1, 2, 3, and then to the right 2. So after 2, I'm trying to connect these points. There we go. I follow this very straight line, you can tell. That's 3 halves x minus 2. All right, these are the 3 pieces of my piecewise function. If I'm going to look at the end behavior of this function, all right, go back to blue. As x approaches infinity, all right, as we go on this side, what is my function doing? Well, this arrow is indicating that the function is going to keep going up and up and up. So as x approaches infinity, g of x, my function, is going to also approach infinity. On the left-hand side, as x approaches negative infinity, as x goes farther and farther that way, my arrow here is going to stay level. It is always, for any number less than -4, it will stay at this -2 spot. So we say that g of x is going to approach -2. It's not going to go up, it's not going to go down, it will stay even.